Before we go into our presentations, we just wanted to highlight our partners who help us make this webinar series possible. So I'll introduce to you the Pacific Northwest Climate Impacts Research Consortium. CIRC is a climate science to climate action team funded by NOAA's Regional Integrated Sciences and Assessment Program. CIRC supports communities, policymakers, and resource managers in Oregon, Washington, Idaho, and Western Montana as they work to adapt to the changing climate. Next slide, please. The USDA Northwest Climate Hub delivers and develops science-based, region-specific technologies and practical information that will assist agricultural and natural resource managers with climate-informed decision-making. And now I bring to you Britt Parker. Next slide.
Thank you, Holly. My name is Britt Parker. I am with the NOAA National Integrated Drought Information System, and I am the Regional Drought Information Coordinator for the Pacific Northwest and the Missouri River Basins. I just wanted to take a couple quick minutes to introduce NIDIS in case you're not familiar with our program and its partners. Our mission is to improve the nation's capacity to proactively manage drought-related risk. And we do this by providing those areas affected with the best available information and resources to assess the potential for drought and better prepare for, mitigate, and respond to the impacts of drought. So we're really looking at trying to improve our understanding of how and why droughts affect society, the economy, and the environment, and to improve accessibility, dissemination, and use of early warning information for drought risk management. And our approach to achieve this goal is to build on the foundation of a national drought early warning system through the development of regional systems where networks of partners and stakeholders share information and actions that help communities cope with drought. We do this regionally because we recognize that the impacts and early warning information will differ across region, and each DEWS, or Drought Early Warning System, has many of the same base ingredients: the need for OBS and monitoring, predictions and forecasting, planning and preparedness, communication, outreach, and interdisciplinary research and application, but ultimately each region will have their own flavor to reflect the needs there. The Pacific Northwest DEWS officially launched in February of 2016. Our strategic plan can be found on drought.gov, and our 4 priority areas include improving monitoring and research for drought risk management, expanding drought early warning communication and outreach, optimizing information and collaboration networks, and enhancing drought planning and mitigation. So please mark your calendars. Our next Drought and Climate Outlook webinar is October 22nd. And in addition, if any of you are traveling to the Northwest Climate Conference in Boise, Idaho in October, we will be hosting a Pacific Northwest DEWS annual meeting on Tuesday, October 9th in the afternoon before the conference launches. So look for the registration information in the post-webinar email today. Finally, before we begin, I just want to highlight the CoCoRaHS network to facilitate early warning. More precipitation observations are needed in the Pacific Northwest, and we encourage you to join the Community Collaboration Rain, Hail, and Snow Network. This is a unique nonprofit community-based network of volunteers for all ages and backgrounds working together to measure and map precipitation as well as condition reporting. And so by using low-cost measurement tools and utilizing an interactive website, the aim is to provide the highest quality data for natural resource management, education, and research applications in all 50 states. And your data can help fill gaps in your area. So if you'll notice the figure on the right, this is of precipitation accumulation for 2 days using only weather stations at the top and weather stations along with CoCoRaHS observer data on the bottom. And you'll notice the increased level of detail in the latter. So your observations of precipitation events and lack of precipitation events are important to capture and improve our understanding of weather. If you're interested in volunteering, these are the state coordinators in each of the states of our region. And I will post the contact information in the chat box as we move on. So thank you, and I will bring up the next presentation.
Next, we'll hear from Nick Bond at the University of Washington, who will give us a climate recap and current conditions.
Yes, good morning, everyone, or good afternoon, depending on where you are. I'm actually going to start out here with a satellite image from last summer, showing a day with quite a bit of smoke across the Pacific Northwest. And we thought that was really unusual and just kind of unprecedented number of smoky days and all that. And then this summer came along, and if we go to the next slide, yeah, there we go. It was a slightly different perspective, but the smoke concentrations in many places have actually been quite a bit worse than last summer. And so a lot of people are naturally concerned and wondering, you know, is this the new normal and so forth. It's not necessarily, but it's still sobering. And I go to the next slide. In particular, if we're actually looking at smoke concentrations here, this is a trace for about 2 weeks earlier this month in Seattle, with the levels above 80, meaning unhealthful for all groups. And so these concentrations well up into the 100s in the Seattle area, or higher than last summer, and definitely kind of alarming. But I have to put that in perspective. And the next slide shows that while people in Seattle were kind of grousing about it, there were plenty of places across the Northwest that actually had worse air quality. And here, the small town of Wenatchee on the east side of the Cascades in Washington State, you can see concentrations here of above 400 micrograms per meter cubed, which is just really bad. And this is a fairly common time series. So this is an indication of just how warm and dry it has been. So if we go to the next slide, in particular, and this is a west-wide perspective on what the U.S. Drought Monitor is showing for the western U.S. as of last week. You can see a lot of yellow and brown colors across the west, and including the Pacific Northwest. And in our neck of the woods, the worst conditions are definitely in the state of Oregon, where there's a patch of extreme drought, and most of the state in severe drought. A little bit better spot is Montana, especially east of the Continental Divide. I can't help but notice that in the desert Southwest, the exceptional drought there, and that has to do with a very poor snowpack from last winter. At least in the Pacific Northwest and in the northern part of the Pacific Northwest, we would have been even in worse situation right now if we hadn't had the abundant snows of last winter. So let's go to the next slide, and what I'd like to show is how we got to the present situation. And here shows essentially the percent of normal precipitation for the last 60 days, ending late last week. Again, in a percent basis, and showing that much of the Pacific Northwest, something like places less than 5% of the usual precipitation, lots of places under 50% of the usual precipitation. So obviously it's been a dry summer. If you go to the next slide, it's also been a warm summer. With here, this is the departure from normal temperature in degrees Fahrenheit, with the orange and reddish colors showing where it's considerably above normal. And there's a few isolated spots that haven't been as bad. And again, Montana is kind of in better shape. But this is why we have the drought we're having. Next slide, please. I want to use a kind of a little bit different perspective and use Portland, Oregon as kind of the poster child. Here shows a time series from the last week of June up until the end of last week, showing the blue bars showing the temperatures each day. That kind of brown band in the middle is the normal range between the max and minimum temperatures, and the blue and kind of pink traces at the bottom and top showing the extremes for each day. And what you can see is very consistently a lot of warm days and warm nights. In fact, there are half as many cool nights as there are cool days in that time series. So it's not that there's been extreme heat waves, it's just been day in, day out. It's tended to be warmer than normal, including at night. Go to the next slide. Another kind of different perspective here is, again, using Portland as an example of the accumulated precipitation. Here I start in May 1st, and that brown line at the top shows the normal accumulation that from May to late last week, and normally Portland would get something like a little more than 5 inches of rain. This year, it's only gotten a bit above 1 inch of rain, and you can see it's basically flatlined since mid-June. Very little has occurred. In the extreme drought year of 2015, we actually got more rain over the period, at least in Portland and across much of the Pacific Northwest. Another year that seems to be that I put in there, 1994, it was wetter in June, but also a similar sort of outcome for the summer months. In many ways, 94 can be kind of an analog year for what we're having right now, kind of going into an El Nino, among other aspects. And Troy will talk about that a little more after me. So next slide. What this is doing to our streams, not surprisingly, is the low flows on a lot of those, especially the kind of rain-fed ones that have their watersheds in lower elevations. Where you see the red dots are where there's much below normal stream flows for the date. There are numerous rivers that are kind of at record lows for the date, and there's a few all-time record low flows. And on the east side of the Cascades, a somewhat better shape. There's a pretty broad range that's considered normal, 25 to 75% of normal. And again, that is, we can attribute to a abundant to decent snowpack last winter. Okay, next slide. So this may be kind of a mysterious parameter here, but I thought worthwhile to put up a map of something called the Evaporative Demand Drought Index. And this is basically showing, it's based on the potential evapotranspiration. It basically shows how thirsty the atmosphere has been for the last month. And there it is, the drier it is, the sunnier it is, and the windier it is, the thirstier the atmosphere is, so to speak. And what struck me about this plot is just how extreme it has been, the atmosphere has been along the Pacific Coast states, including especially west of the Cascades, where we've just seen this day in, day out, warmer temperatures and low humidities. And so there's a lot of energy there to pull water out of the system. Okay, next slide. I like to look at the regional atmospheric circulation patterns as a way to kind of understand, what we're seeing in the weather. And here, this is showing 500 millibars or hectopascals, is about 20,000 feet up in the atmosphere, and it's a place where we can look at the large-scale circulation patterns. These reds show where they're higher heights, essentially higher pressure than normal there, and this kind of pattern is conducive to sunny skies, sinking motion, warmer than normal temperatures, and certainly that's what we've had in the Pacific Northwest. And this particular map goes back the last 60 days or so, from late June to the middle of last week. If we compare that map, just burn that in your retina, to the next slide, here what we had in 2017, which was also a warm and dry and smoky summer. We also had these kind of high heights over the Pacific Northwest, but a somewhat different pattern. And the message I want to get across here is that the regional circulation can in large part explain the sort of conditions we've seen this summer. Of course, there is climate change is occurring and that sort of thing, but it's kind of the unusual weather patterns that are mostly to blame. All right, next slide, and I think it's my final content before just some remarks. And here, this is a map of the sea surface temperature anomalies just for a particular day at the end of last week, with the yellows and oranges showing where the water is warmer than normal and the blues where it's cooler than normal. And for much of the Northeast Pacific, it is warmer than normal. It's not as warm as it was a couple of years ago. When the water is really warm off our coast, the prevailing winds that are coming from the west are kind of warmed that much more than usual. And so that effect has been occurring to an extent this summer, but not to the same extent as in 2015 especially. You can also see that there's some warm water in the tropical Pacific, especially the central tropical Pacific, and they're, maybe stealing a punchline from Troy, but I expect he'll be talking a little bit more about that. So with my very last slide, just to briefly sum up, here again in 2018, we've had a dry, warm, and smoky summer for the Pacific Northwest. We're seeing the impacts and stream flows, especially on the west side of the Cascades. Some of the smaller water systems are having problems keeping up with the demand. And last point here to make is that, this unusual weather has been associated with some really substantial kind of circulation anomalies. And with that, I appreciate your interest and attention. And I guess I'll turn it over. I'm not sure exactly how they're going to be doing it, but certainly you can submit questions to the chat room, and I don't know whether we want to take those now or at the end, but either way.
We'll take the questions at the end. Thank you, Nick. Yep. Okay, if we can switch presentations, then we will just change our order here a little bit and hear from Julia Ostapio from the Oregon Water Resources Department and Oregon State University, a qualitative active approach to drought impact collection.
Okay. Can you see my presentation okay?
Yes.
Okay. Okay, great. So yeah, my name is Julia Ostapio, and I am presenting a pilot drought impact project on behalf of the Oregon Water Resources Department. So just a brief overview. So I'll give you some background and project overview and some preliminary findings. First, to provide you some background on this project, in 2015, Governor Kate Brown identified drought as a reality for which Oregon needs to build resiliency by issuing the executive order calling for state agencies to build drought resiliency measures into the integrated water resources strategy. Then in 2016, the Oregon legislature established a drought task force to develop recommendations that could help improve the state's response to drought. And the task force made several recommendations, one of which is here on the slide, to document the economic, social, and environmental impacts of drought, including frequency, distribution, intensity, and duration. Therefore, this is a pilot project in an effort to address the recommendation listed in the 2017 Water Resources Strategy Plan. And Oregon Water Resources Department decided to take a qualitative approach, conducting semi-structured interviews to collect drought impacts this summer of several Oregon sectors. So I was the only one who was conducting these interviews. So the scope of the project is probably a little bit smaller than hopefully the future projects. But I interviewed several state agencies, a couple of the Water Resource Department water masters. We went through OSU Extension Services to interview agricultural representatives. Then we interviewed a couple members of the Oregon Water Utility Council, a few recreational business owners, and we're able to interview one tribe representative. And the majority of the interviews were conducted over the phone between July 20th and August 15th of the summer. I conducted a total of 30 interviews, and we also received some email responses. And just to give you an example of some of the interview questions we asked, they really kind of focused on basically impacts that different community sectors, businesses, the agriculture sector is experiencing, whether it's economic or other impacts, and whether the drought this summer affected their operations in any way. So the current phase of the project is consolidating all of the information that was collected during the interviews and inputting it into Survey 123 for ArcGIS. And so this is the back end of the form that I'm using to fill out. And some of the information that was collected was the date of the interview, which sector the interviewee represents, interviewee's primary location, and description of the jurisdiction of the narrative. So whether it's a city, a county, a water master district. And there will also be a summary of salient impacts mentioned during the interview, and also any relevant attachments such as pictures, links, or reports that the interviewee decided to share with us. And the last question of the interview focused on the overall impact of drought this summer from the interviewee's perspective and the sector they represented. So myself with a couple other members from the Water Resources Department developed a scale from 0 to 4, where 0 is an above average year, all the way to 4, which is devastating. And I asked all the interviewees to kind of place themselves among the scale. And the information will be presented in our GIS story map or storyboard. Once again, the image you're seeing on the screen is the back end. So this is where it's not published currently. And it will be hosted on the Water Resources Department website and will be open for public view sometime mid-fall. And as you can see, I think right now I have maybe 4 interviews entered so far, but you'll have different points on the map, and then it's color-coded with the sector that they represent. We have the impact drought scale, the story, the organization they represent, the region, and if you scroll down, any pictures or attachments will also be visible. And the formatting of the story map is a work in progress and is being handled by the GIS team at the Water Resources Department. And here are the results so far of the impact scale interview question. So this is a more quantifiable question. So far, I received 16 of the interviewees indicated an average to mild drought impacts this summer. 7 interviewees indicated moderate drought impacts this summer. And 3 of the interviewees indicated severe drought impacts. And the part that I found the most interesting is all of the severe drought impacts came from South Central Oregon. And just to summarize, I assisted the Oregon Water Resources Department this summer and collected narratives around the 2018 drought. The information collected during the interviews will be hosted on the Water Resources website. And hopefully Water Resources Department will get more resources in the future to collect drought impacts on a continuous annual basis. And if you have any further questions regarding this project, obviously at the end of the presentation or at the end of the webinar, but you can also email me if you have any questions or follow-up information. So that's concludes my presentation. Thank you.
Thank you very much, Julia. Now we'll go back to Troy Lindquist's presentation. Again, he'll be talking about the seasonal conditions and climate outlook. Troy, are you on the phone with us?
Can you hear me?
I can.
Perfect. We'll start off talking about the El Nino Southern Oscillation Status and what we expect this to look like as we move into the fall and the winter time. So my first slide here is of the sea surface temperature anomalies over the Pacific Ocean. And we're going to focus along the equator, so right along the 0-degree latitude line, right in the middle of the image from left to right. And this is back in May, so springtime. Just for comparison, the cool colors or blues are the below normal temperature anomalies, and your warm colors, yellows, reds, are the above normal. So really want to focus on kind of the central and eastern part of the Pacific in these images. So we'll just jump ahead from this image to last week, August 20th, sea surface temperature anomalies. So you can see quite a bit of warming, particularly over the central and eastern part of the equatorial Pacific. And that's right in the Niño regions that we like to study when seeing what ENSO is doing. So we have the Niño 4, Niño 3, 3.4, and Niño 1 and 2 regions. I've highlighted Niño 3.4 in the thick black box there, just because we'll come back to that in another slide shortly. Another way to look at the sea surface temperature evolution is look at these various Niño regions individually, and we're going to look at our graphs on the right, and this goes back to about a year ago, September 2017, showing on the left side of each scale, and it goes to the current conditions on the right through the summer and August. But if you look at each of those Niño regions, especially the Niño 4, Niño 3.4 and 3, you can see we transitioned from La Niña last winter, and as we moved through the spring, April, May, and June, we actually went to positive anomalies, and that takes us to where we're at now. We're above average for our sea surface temperatures, but still in that what we call neutral phase of ENSO. So where are we going to go from here? Well, if you look at all the dynamical and statistical models on this graph, there's pretty good consensus that we are going to go from neutral, which is the black line here with the black dot. And if you go down to our time scale along the bottom of the graph, that's July. And as we move to the right in our time scale, those are 3-month chunks of time. So the JAS is July, August, September. Then the next is August, September, on October, and so forth. So the forecast is pretty definitive that we're going to go above that 0.5 degree Celsius sea surface temperature anomaly sometime this fall. And that looks like the models are showing that to continue through the winter and then gradually start to sink back down towards neutral conditions as we move into the springtime on the far right of the scale. So if we look at this from a probabilistic standpoint, again, we're looking at 3-month blocks of time across the bottom. So July, August, September. If we go right towards the middle of the graph, that's November, December, January, that transitions from fall to wintertime. And the red bar there is El Nino conditions, and that's favored by about 70% of probability is by the time we get to winter. So pretty strong odds that we'll see El Nino conditions by the time we get into winter. So why is that important? Well, ENSO is pretty good predictor on as far as indicating what kind of impacts the weather patterns are going to have during the winter time over North America. And this image here shows during El Nino episodes what we typically see as far as impacts on our climate conditions. We typically have warmer than normal conditions across the northern tier states. And if you go across the southern U.S., we tend to see an active jet stream across that region and wetter than normal conditions. So just wanted to point this out because we'll see these reflected in our long-term outlooks as we go into the winter time with El Nino conditions favored. But before we get to those seasonal outlooks, we'll look at the 8 to 14 day outlook. So this is basically through the first week of September, and it looks like we're going to continue to see kind of a cool weather pattern for the next week or two, actually, across the Pacific Northwest and Northern Rockies, with kind of a troughing pattern dominating across the region. And that's what this 8 to 14 day outlook reflects. You can see the blue below normal shading on the left over parts of Washington into western Montana. So that's favoring below normal temperatures. If we go to the right on the precipitation outlook for that period, you can see over the Cascades probabilities pointing towards below normal precipitation. And if we move into the Northern Rockies, western Montana, just a slight lean towards above normal precipitation over the next couple of weeks. So as we move into the 1 month outlook, just wanted to point out when you look at these maps, the shading really pops out at you. And in this example for Boise, we're fairly strong indications favoring above normal temperatures, but that's not the only possibility when you look at these maps. So there's also a 33% chance of having normal temperatures during this period, or even a smaller chance, 11% in this case, of having below normal temperatures. So just keep in mind that there are some other possibilities still when you look at these outlook maps, but they're just shaded areas point towards the favored category expected. And you can get individual probabilities for specific locations by going to the Climate Prediction Center interactive map section of their website. And we can do the same by looking at the precipitation probabilities for 1 month. In this case, in Seattle, 46% probability of below normal precipitation, but still some other possible outcomes, but less favorable. So let's look at the October, November, December, or the fall outlook. Again, odds are that we'll see above normal temperatures across the Pacific Northwest. And if we look at precipitation, again, keep in mind that we are expecting a transition into the El Nino or warm phase of ENSO. So we do have probabilities leaning towards drier than normal conditions during the fall period. And finally, for the core winter months, December, January, and February, again, if you think back to that El Nino impact for North America graphic I showed, you can see we have probabilities favoring warmer than normal temperatures across the northern tier states, and the drier than normal conditions for precipitation across mostly just the northern Rockies, which is really important for our snowpack, because that's very key for our water supply and getting us through that warm, dry season that we normally see during the summertime. So the seasonal drought outlook, before I show you the outlook portion, I just wanted to recap the latest drought monitor map from last week. Oregon being the focus for drought across our region, with the rest of the Pacific Northwest being in another category of lesser drought or just abnormally dry. If we look at the seasonal drought outlook, you can see that dark brown areas we expect drought to persist, and even an area in much of the eastern half of Washington and part of northeast Oregon where we expect drought development to be likely. So not good news with our drought situation. So I wanted to move on to possible stream flow and water supply impacts as we move into the wintertime and look at the pretty good potential to have El Nino impact us. So what we're looking at here is a water supply runoff volumes that we've had historically, and they're broken up in, well, the scatter plot has it during La Niña, you see in the blue or on the left half of the graph, or neutral conditions of ENSO in the middle, and El Nino conditions on the right. The green line across the middle of the chart here is the average for 30-year average runoff volume. And again, this is for the April through September period. So you can see during El Nino episodes, if you look at our trend line, there's definitely a trend of having below normal runoff volumes during that April through September period. So, and the expectations would be for less than average runoff volumes for our water supply as we start to see our snowpack runoff next spring into the early summer period. But not all of them turn out that way. You see there are some outliers that ended up with above normal runoff during El Nino phases. But for the most part, we see the below normal runoff during that period. And that's in the Upper Snake region. Let's take a look up in British Columbia. And we see a similar trend showing up in the trend line here. Most El Nino years we see below normal. It may not be a lot, but it is below normal runoff volumes during that April through September period. And finally, we'll shift over to the Willamette region and just look at a point there. And we see a similar trend there during El Nino with below average runoff volumes during that period. And finally, just a slide to show our significant wildland fire potential outlook. And this was created August 1st. It'll be updated here shortly by the folks at the National Interagency Fire Center. Just a couple of comments here. As our days get shorter, angle of the sun gets lower. We're seeing, of course, cooler temperatures, longer nights, and the shorter burning periods, basically, so higher humidity. So our significant wildland fire potential is definitely decreasing just from a climatological standpoint as we move into the fall. But nonetheless, with the drought and as dry as conditions have been across the Northwest, we could still see some pretty active fire conditions across the region. But as we, again, move towards the fall, the potential for very large wildfires is going to be gradually diminishing no matter how you look at it, just because of the cooler temps and higher humidities. And finally, just in summary, as far as the ENSO status goes, El Nino watch is in place, and about a 60% chance of El Nino conditions developing this fall, increasing to about 70% for the winter. And the winter outlook, we're calling for above normal temperatures favored across the region, with below normal precipitation for the Pacific Northwest and Northern Rockies during the fall, and more so over the Northern Rockies during the winter, and looking for drought conditions to persist over much of the Pacific Northwest over the fall and wintertime period. And that's all I've got.
Thank you very much, Troy. For folks who have questions for Troy or any of the other speakers, please put them in the question box. Now we will move to David Peterson at the University of Washington, who will talk about climate risk management practices.
Thank you, Holly. Can you hear me okay?
I can.
All right, very good. Well, let's get started. And it was great seeing the other presentations so far in the webinar. Looks like there is a bad ski season ahead, but maybe that will turn around. This presentation will be a little bit of a shift from some of the other information that we've heard this morning, and it will be pretty much data-free. So I hope that will still retain your interest. This is a very brief summary of a project that has been completed recently in collaboration with the USDA Northwest Climate Hub. So we've been working closely with Holly on this. And I just want to go over the basics. Okay. First of all, one of the motivations for this is that we have a tremendous amount of information already on climate change assessments and risk assessments. There's literally thousands of journal articles that we have about climate change data, climatic variability data, effects of climate change, tools, models, just almost endless websites and different types of documents that represent this information. So we really do know a lot about climate change, including some projections. And when I talk to my friends who are in resource management, they tell me that they kind of feel like this. And actually, I kind of feel like this too, in terms of actually trying to keep up with the amount of information that's coming out on climate change and more recently on drought. So I would suggest that we need to perhaps focus more of our effort proportionally to connect this scientific information with actual management and planning applications in the future, because there really is a huge need for that across public lands throughout the United States. Let's just start with quick definition here. We're going to talk about climate change, but also talk about drought. But when people talk about climate change adaptation, sometimes they mean different things. The little cartoon here indicates, again, I think, how our resource managers feel. They have to make some choices, but those choices are difficult, and pretty much no matter what you do, somebody's not going to be happy with you. But in terms of a definition, I like to refer to climate change adaptation as an effort to reduce potentially negative consequences of climate change and drought, and also to be part of this transition process for species, systems, and organizations that manage natural resources. So we like to remember that last part about the organizations needing to adapt as well. For the most part, our public agencies are already doing a lot of things which we might call climate smart. So we're really focused in many cases on doing fine tuning and prioritization. Adaptation is simply another aspect of sustainable resource management and becoming more so. It's also part of building resilience in systems and organizations, and some people like to refer to building resilience instead of adaptation. And then finally, it's a form of risk management. And this is something that our natural resource managers do all the time anyway. They assess the likelihood of different things happening out in the landscape, whether it's fire or floods or tree growth or tree mortality, and then they design ways to deal with it. I'm just showing the word drought up here to show that I think that climate change and drought are fairly interchangeable when we talk about this particular topic. So a few years ago, our team developed the Climate Change Adaptation Library for the Western United States as part of our Adaptation Partners website. And this is intended to provide options for resource managers who are really anxious to get going on climate change adaptation. Jessica Halofsky and Joanne Ho, part of our team, who you saw on the author page, did most of the heavy lifting on this. So this library has over 500 adaptation options for a wide range of different resources. This is not necessarily the be-all, end-all, but it is a place where people can start. And we found that managers really like this because they don't have to brainstorm everything from scratch. Now, all of these adaptation options were developed by resource managers and stakeholders. So this is not some scientific pie-in-the-sky sort of thing that was developed in isolation. All of these options were elicited from those managers and stakeholders at workshops. So we feel like they are heavily invested and supportive of this effort. When we were challenged by Holly and the Climate Hub to move this toward a little different direction with climate, we built on the foundation of the library and decided to identify those practices that would be most relevant for resource managers in the Northwest. You can see the link below there that has a PDF that you can download, but it's a lot easier to look at this on the website. That's quite a URL, but I'm sure you can find it if you go to the Climate Hub website. So just a very brief look at what this looks like. Climate risk management practices are identified here for these categories: hydrology, vegetation, riparian areas and wetlands, fish habitat and fisheries, wildlife, and recreation. And we anticipate that this database of adaptation options, in this case, risk management practices, will continue to grow. Now, why risk management practices? That's because most of the public agencies are already accustomed to the terminology of best management practices, or BMPs. And so that's institutionalized. That makes it very easy for us to use a similar type of terminology and a similar type of approach to articulate ways that climate can now be addressed. So this is a bit of a new term, risk management practices, and we're anxious to see how widely this will be used in the future. So just a couple of quick examples to give you an idea of what this looks like in practice. So for hydrology, water uses and infrastructure, one of the primary sensitivities identified is that lower stream flows will cause higher demand and competition for water by municipalities and agriculture. And I've selected this specifically because it is related to drought. So a strategic approach is to restore the function of watersheds to promote water storage. Note that this is a resilience type of approach. And this is a list of some of the climate RMPs that are in the database. There are actually another 4 or 5, I think, that I didn't show here. Reconnecting floodplains, protecting and restoring groundwater-dependent ecosystems, maintaining large wood and riparian areas, promoting beavers, and appropriate livestock grazing. So again, I want to emphasize these were all generated by resource managers, so we feel like it has their seal of approval. Okay, let's go to the next example, and this one is for forest vegetation. Sensitivity here, again, drought related, is that warming temperatures will increase drought stress. We've seen some significant examples of that in the last few years in the Northwest and elsewhere. A strategic approach is to manage stand density to maintain tree vigor and increase resilience to drought. And then some risk management practices include thinning of dense forests, promoting tree size and age diversity, promoting drought-tolerant species, and using prescribed fire. Now, you'll notice that many of these different risk management practices are things that are already occurring on a lot of our public lands. So the risk management practices may just be a tweak or a reorientation or reprioritization of certain types of actions on the ground. But we hope by having all of these risk management practices in one place and an easy-to-use menu that it will be conducive to people really, having a kind of a one-stop shopping location for this information. So just to sum up, there are a lot of options available for managing the effects of climate and drought, and I do hope that these climate risk management practices will be useful, or at least be a place to start for folks who are also interested in drought. These RMPs can be considered by resource managers in the public lands in addition to the BMPs, or best management practices, that they already have. So this just gives them another little weapon in their toolkit. We feel like most of the climate RMPs are roughly equivalent to drought RMPs, and so there's no reason why additional drought RMPs cannot be developed and customized. And then finally, federal agencies are already using these things in practice. In fact, at the moment, we're compiling a number of examples and case studies around the Western U.S. in which federal agencies and other public agencies are already implementing things on the ground using some of the information that you just saw on the screen today. So I'll close there. These are some URLs that you can take a look at later at your leisure. We're always interested in feedback and the usefulness of this information. And if you would like any more information, please feel free to contact Jessica or myself. So I'll stop there, Holly.
Excellent. Thank you very much, David. If folks have questions, go ahead.
Sorry, this is Britt. David, I'm just going to leave your screen share up so that people can copy down those. So I'm going to leave your screen up for now.
That's fine.
In addition, I also put the links to the adaptation partners and the Climate Hub climate risk management practices in the chat box. And Britt also added in the COCORA's coordinators if folks are interested in getting that information. So I can, the only question that I've seen come in through the chat box was just asking if why so many USGS markers were not ranked, and if Nick, if you wanted to address that.
And I'm afraid that I have to plead ignorance. I suspect it could be that they only rank those with a long enough record so that it's a meaningful ranking, but that's purely a guess. And I can look into that, but I'm afraid I just don't know the answer right off the top of my head.
Okay, thank you.
Muted.
Open the unmute everyone if I can. Maybe I don't have permission to do so. So for folks, if you have questions, let's see. The question for Dave, did you find conflicting adaptation practices for particular situations? If so, did you handle that in the library? And I'm not hearing from Dave. Julia, are you still on the line? So Julia, the question for you is, did you see any correlations between the industry your interviewee was from and how they perceived the drought, mild versus moderate, or was it worse for certain industries?
That's a tough one. I would say that, I guess the best way I can respond, so I am in the process of still kind of going all of the information I collected and writing up summaries, but so far, I would say the ones that tended to rank the impacts, I would say as more severe, were the ones that represented the agricultural industry. And bear in mind, for the agricultural industry, I wasn't interviewing the farmers themselves. I was interviewing with individuals who work for OSU and work with farmers. So I think that could be a potential validity issue. But yeah, agricultural industry ranks the drought more severely. And then also the water masters did as well. And I would say the recreational industry did seem relatively hesitant to demonstrate the severity of the drought because I think it directly reflects on their business. So I don't know if that really answers the question, but.
And there was an additional question just asking why only one tribe was interviewed for your project.
Right. Okay. So once again, first of all, it's capacity issues. I'm just an intern this summer and I volunteered my own time to do this. And second of all, originally, so I went through an agency to receive, actually I went through Oregon Health Authority with a representative there to receive contacts to tribal members that I could contact, and I received 2 contacts. And unfortunately, one of the contacts there was a long process to get approval for them to even conduct an interview with me, so that ended up not working out. So it was just more of accessibility and timeline limitations.
Okay, thank you. And Karen, I will connect you with David to give you feedback on your question. We're at the top of the hour. Thank you all for joining us. A recording of the webinar will be available on drought.gov later this week. And thank you very much to all of our presenters.
Thank you, everyone. Bye-bye.